Most architects assume foundational code work. One occupancy, one construction type, one set of allowable numbers covers the exam. On test day, you find out it doesn't. The prompts in PPD mix occupancies, add sprinklers, demand refuge for people who can't take stairs, and sit on lots that zoning quietly clipped before the code analysis even began. Miss any single layer, and a prompt that looked solvable on paper will cost you the question. And on a real project, missing the same layer is what gets the firm sued. The Advanced module exists to teach you how the layers stack and which layer controls when two of them disagree. Here are 4 reasons the Advanced layer sits this high on the exam. 4 reasons this Advanced layer carries the weight it does. First, separated mixed use is a calculation, not a concept. The IBC asks you to take the actual area of each occupancy, divide it by the allowable area for that occupancy, and confirm the sum across all occupancies is 1 or less. Get the denominator wrong on one occupancy and the whole building fails. Second, automatic sprinklers aren't just a fire suppression decision. They unlock additional area, allow taller buildings, and extend travel distances. The IBC uses sprinklering as the gating variable across half a dozen tables, and the exam tests whether you applied each allowance correctly. Third, areas of refuge and accessible dwelling unit ratios are threshold-driven. They kick in above a specific story count or unit count, and the exam writes prompts that sit right at the threshold to see if you know which side you're on. And fourth, zoning sits outside the IBC entirely. Setbacks, floor area ratios, and height limits can shrink the building before any code analysis even starts. And the right exam answer often hinges on which document controls. Here are the 5 advanced subsections in the order the exam stacks them. Walking the 5 advanced cases. 4.1 is the separated mixed occupancy calculation, the fractional sum from IBC Chapter 5 that decides whether a building with multiple uses fits inside its allowable area envelope. 4.2 is automatic sprinkler systems and the cascade of allowances they unlock: additional area, additional height, longer travel distances, and sometimes 1 less hour of fire resistance rating. 4.3 is areas of refuge and rescue assistance, the accessible holding zones required at certain story thresholds for occupants who can't use the stairs in an emergency. 4.4 is accessible dwelling units in multifamily buildings, the ratios of Type A and Type B units required, and where the threshold actually triggers them. And 4.5 is the zoning overlay, setbacks, floor area ratio, and height limits that come from the municipal code, not the building code, and routinely cut into what the IBC would otherwise allow. One posture shift before we step into section 4.1. 4 things to hold in mind as we walk these advanced cases. First, advanced code questions reward stacking. The exam rarely tests one rule in isolation. It tests 2 or 3 together, and your job is to read all the layers before choosing an answer. Second, when 2 rules disagree, the stricter one controls. The exam writes those conflicts on purpose, so when you see a prompt where the IBC says one thing and zoning says another, the smaller of the 2 numbers is usually the right answer. Third, sprinklering is the single most common allowance multiplier in the code, but the bonus only applies if the building is actually sprinklered. Read the prompt for that detail before applying any area or height increase. And fourth, zoning is silent in the IBC, but it controls in real projects and on the exam. Setbacks, floor area ratio, and height limits from the municipal code can shrink the building before any building code calculation even begins. With that posture set, we step into section 4.1. Walk into a schematic design review with a mixed-use building and watch what happens. Most architects treat occupancy classification as a checkbox. Pick one, move on. That's how a Group A restaurant tucked into a Group B office tower drags the entire building down to A occupancy limits and triggers a redesign that should have been caught in week 2. Miss this and you fail the exam question. Miss it in practice and your firm absorbs the schedule slip. Separated mixed occupancy is the alternative. You place a fire barrier between the uses, and each portion is evaluated independently against its own height and area limits under Section 508.4. The trade is real. You buy back the looser limits on each portion, but you pay in fire resistance rated construction and continuous detailing through the barrier. The IBC tests this by handing you two adjacent occupancies and asking what hours of rating belong between them. The methodology is a 4-step sequence, and skipping any step is how the wrong rating ends up specified. Step 1 is the diagram. Every adjacency on the plan tagged with its 2 flanking occupancy groups before any rating is looked up. Step 2 is the table lookup. Table 508.4 is a 2-axis matrix. You read it left to right, and the cell gives the rating for that adjacency. Step 3 is the sprinkler bonus. Each cell shows 2 numbers separated by a slash. The sprinklered rating, then the unsprinklered rating, or the abbreviation NS, meaning the combination is forbidden without sprinklers. That bonus typically cuts the barrier in half. Step 4 is the fire barrier detailing per Section 707, and it is where architects lose exam points and field disputes. A fire barrier must be continuous through concealed spaces. Opening protectives must be rated at 75% of the wall, and joints must be smoke resistant. Spec a 2-hour barrier and forget the matching 90-minute door, and the inspector cites you. Here are the most tested separations on the exam, drawn straight from Table 508.4. 4 pairings show up over and over again on exam scenarios. Assembly to business is 1 hour when sprinklered and not permitted without sprinklers, which is why every restaurant in an office tower comes with an automatic sprinkler line item. Business to mercantile needs no separation when sprinklered, but jumps to a 1-hour barrier when unsprinklered. Assembly to S1 storage demands a 2-hour rating sprinklered and is forbidden without sprinklers. And educational to S1 storage is the rare case where unsprinklered separation is still allowed, at 1 hour, because the sprinkler bonus drops it from 2 hours down to that. The pattern is consistent. Sprinklers buy you either a reduced rating or, more often, permission to build the combination at all. On a typical Assembly Plus storage program, separated occupancy without sprinklers is a non-starter, and the exam wants you to recognize that before you waste time pricing barrier construction. Separated occupancy is the right call in some scenarios, and the wrong one in others. Here is how to tell the difference. 6 scenarios where separated occupancy beats the non-separated approach, and they all share one pattern. The restrictive use is small relative to the rest of the building. A 5,000 square foot Group H hazardous use room inside a 200,000 square foot office building is the textbook case. Non-separated would force the entire building to comply with H occupancy area and height limits, which collapses the project. Separated lets the H stay H and the B stay B. The second test is whether combined height or area would bust the most restrictive limit if you went non-separated. If yes, separation is mandatory in practice. The third is cost. If you're building Type 2B already, adding a 1-hour barrier is a marginal upcharge. The fourth is owner intent. If they want to convert the restrictive use later without re-permitting the whole shell, a barrier preserves that optionality. The fifth is operational, especially in K-12 work, where a school adjacent to a storage building needs acoustic and security separation regardless. And the sixth is the unsprinklered case. If the combination is NS without sprinklers and the owner refuses to sprinkler the building, separated occupancy is your only legal path. Walk away with this as the playbook for any mixed-use schematic design review. 5 takeaways from the separated mixed occupancy framework. First, each separated portion is evaluated independently against its own height and area limits. That is the entire point of the strategy. Second, Table 508.4 ratings always come paired. sprinklered on the left, unsprinklered on the right, and NS means the combination is not permitted without sprinklers. Third, the sprinkler bonus typically cuts the required rating roughly in half, or it unlocks combinations that would otherwise be forbidden. Fourth, the fire barrier is governed by Section 707, not the mixed occupancy chapter, so continuity through concealed spaces, opening protectives at 75% of wall rating, and smoke-tight joints are part of the spec or you have a violation. And fifth, the right call for separated occupancy is when the restrictive use is small, when combined limits would bust the most restrictive group, or when the owner needs flexibility to change the use later. Non-separated mixed occupancy is the option architects reach for when they want a clean plan with no fire barriers chopping up the floor plate. It is also the option that ends careers when the analysis is done wrong. The rule is brutal in its simplicity. When you do not separate the occupancies, the entire building must comply with the most restrictive requirements of every occupancy present. A 2,000 square foot Group A2 restaurant sitting on the ground floor of a 5-story Group B office tower can drag the entire tower down to A2 limits, which means a 3-story cap and a redesign that costs the firm 6 figures. Fail this on the exam and you lose the question. Miss it in practice and the building official rejects the permit set and the schedule blows. The exam writes the trap deliberately, and the trap works because most architects underestimate how aggressive the most restrictive rule actually is. The analysis is a 3-step sequence. Get the steps in order and the answer falls out. Step 1 is identification, and it is where lazy analysis fails. Every occupancy in the building counts, even the small ones. A coffee bar inside an office suite still classifies as assembly if the occupant load pushes past the assembly threshold. A storage room with combustibles still classifies as S1. Mistag any space, and the rest of the analysis is wrong, and the inspector finds the error before you do. Step 2 is the comparison, and it is mechanical. For each parameter the IBC governs, allowable height in feet, allowable height in stories, allowable area, allowable construction type, you find the occupancy with the lowest number and write it down, side by side in a table with columns for each occupancy and rows for each parameter. Step 3 is the verdict. The worst case from Step 2 becomes the limit for the entire building. If that limit makes your design infeasible, 3 stories when you need 5, 15,000 square feet when you need 50, then non-separated occupancy is the wrong strategy, and you go back to separated. The exam will hand you 4 occupancies and ask which limit governs. Do the comparison, and the answer is unambiguous. Once the math is in front of you, the choice between non-separated and separated becomes a clear trade. Non-separated keeps the floor plate open and clean. No fire barriers chopping through the design. But the price is a single ceiling on the whole building, set by the most restrictive occupancy present. It is the right call when every occupancy in the program has similar height and area limits, because then dropping to the worst case costs you little. It is the wrong call when one occupancy is small and very restrictive, because a 5,000 square foot Group H in a 100,000 square foot office building would force the entire building to comply with H limits, and that's a non-starter. Separated is the inverse trade. You spend money on fire-rated barriers and matching opening protectives, but you buy independent sizing for each portion. The small Group H gets H limits, the rest of the building gets B limits, and the project actually pencils. On the exam, weigh the relative sizes and limits before you commit to either path. If the dominant occupancy is also the most restrictive, non-separated is essentially free. If a small restrictive occupancy is hidden in a bigger building, separated is the only honest answer. The most common exam trap shows exactly how aggressively non-separated occupancy compresses a building. 3 stories. That is the cap on a 5-story design when a small Group A2 restaurant lives on the ground floor and the building is run as non-separated mixed occupancy. The A2 limit for Type 2B construction is 3 stories. The B limit is 5. Under non-separated, the lower limit governs the entire building, so 2 stories of program vanish, gone, redesigned out, fee written off. NCARB writes this scenario deliberately because most architects fixate on the dominant occupancy, see business, and assume B limits apply. The most tested mixed occupancy trap on the exam is exactly this geometry, and miss it and you fail the exam item. The fix is either to separate the A2 with a fire barrier, buying back the B height limit on the rest of the tower, or to relocate the A2 entirely. Either move is cheap compared to redesigning 2 floors out of a permitted scheme. Walk away with these 5 anchors so the trap stays visible in every schematic design review. 5 anchors from the non-separated analysis. First, the strategy skips fire barriers between occupancies, but applies the most restrictive limits of any occupancy to the entire building. That single sentence is the rule. Second, every occupancy in the building counts in the comparison. The small ones are usually the ones that bite. Third, run height, area, and construction type side by side in a table before committing. Guessing gets you the wrong answer. Fourth, when one occupancy is small and very restrictive, sitting inside a larger building of a looser group, separated occupancy is the only honest choice. And fifth, if step 3 of the analysis yields a worst-case limit that makes the project infeasible, switch strategy immediately. Do not waste fee redesigning under a constraint that cannot be satisfied. Here is what most architects underestimate about Section 509. An incidental use area is what the IBC calls the middle ground, a space too small or subordinate to classify as a separate occupancy, but too dangerous to ignore inside the surrounding use. A furnace room burning natural gas inside an office building is the classic example. It's not big enough to drive a mixed occupancy analysis, but the fire load is real, and the room needs protection. Section 509 and Table 509 prescribe exactly what protection, either rated separation, sprinklers, or both. Architects who treat these as afterthoughts get cited in plan review and waste a permit cycle fixing what should have been correct on the first set. Fail this on the exam and you lose the question. Miss it in practice and the inspector flags the drawing back to you. 3 incidental uses appear on almost every exam, and the protection pattern follows a strict logic. An incidental use is formally a use that supports the main occupancy of the building, but poses a hazard above what the main use would otherwise allow. The key word is supports. The space exists to serve the dominant function. A furnace room supports a Group B office building. A laundry chute room supports a Group R hotel. An incinerator room supports a Group 1-2 hospital. These rooms are too small or subordinate to be classified as their own occupancy under the mixed occupancy rules of Section 508, so the IBC carves them out and handles them separately under Section 509 and the specific list in Table 509. Confuse the 2 PABs and you draw the wrong barrier, fail the exam question, and have to redraw the plan for permit review. Here are the 3 incidental uses that show up repeatedly on exam scenarios. 3 incidental uses cover 90% of exam questions on this topic. A furnace room above 400,000 BTU is the simplest case. 1 hour separation or sprinklers, your choice. Most architects pick sprinklers because the cost is marginal in a building already designed with NFPA 13 throughout. A hydrogen fuel gas room raises the stakes. 1 hour separation and sprinklers, both required, no choice. Hydrogen burns hot and fast, and the IBC does not let you pick one protection mode. An incinerator room is the most demanding case in Table 509. 2 hour separation and sprinklers, both required, again, no choice. The pattern is consistent. As the hazard climbs, the choice of protection narrows and eventually disappears entirely. The single word that decides whether you choose protections or stack them is the difference between a passing answer and a fail. The single word that decides the protection strategy is small enough to overlook on a fast read. Or means choice. 1 hour separation or sprinklers. Pick the path that fits the design. That's the rule for moderate hazard incidental uses, like furnace rooms above 400,000 BTU, laundry rooms, and most storage rooms. In a building already designed with sprinklers throughout, architects routinely omit the separation under the OR rule and use the sprinkler-only path, which is correct and economical. And means both. 1 hour separation and sprinklers, layered. That rule is reserved for severe hazard incidental uses, like hydrogen fuel gas rooms and incinerator rooms. Even when the rest of the building is fully sprinklered, the rated wall around an AND rule room is still mandatory. Substitute OR for AND on a hydrogen room, and the inspector cites you for a missing fire barrier, the plan goes back and you fail the permit cycle. Substitute AND for or on a furnace room, and you've over-designed the building, but at least the code is satisfied, though the owner will not be amused by the construction cost. Walk away with these 5 anchors so the and/or distinction stays at the top of your code review checklist. 5 anchors from the incidental use framework. First, an incidental use is a hazardous space too small or subordinate to drive a separate occupancy. It supports the main use of the building, but carries elevated risk. Second, the regulating rule is Section 509 and Table 509, separate and apart from the Section 508 mixed occupancy machinery. Third, the table uses OR and with precision. OR means pick one protection mode, and means both protections are layered together. Fourth, hydrogen fuel gas rooms and incinerator rooms always sit in the AND category. Both separation and sprinklers are required, no exceptions. And fifth, never memorize a default protection pattern across all incidental uses. Read Table 509 row by row for every project, because the wording shifts and the wrong default fails the inspection. Most architects treat the special occupancy chapters as edge cases until the building geometry tips them in, and then the redesign cost the firm 6 figures. 3 chapters live in the IBC, each triggered by a single condition that drives a complete protection package. High-rise, Section 403, is triggered when the highest occupied floor sits more than 75 feet above the lowest fire department vehicle access. Atrium, Section 404, is triggered by an opening that passes through 2 or more stories without being a stair, elevator, or shaft. Covered mall, Section 402, is triggered by a covered pedestrian zone connecting anchor stores. Fail this on the exam and you lose multiple linked questions. Miss it in practice and you get sued by the owner when the redesign blows the schedule. The 3 triggers and 3 packages are best learned in a side-by-side table. High-rise under Section 403 is the most tested of the 3. The trigger is simple. Highest occupied floor more than 75 feet above the lowest level of fire department vehicle access. Hit that threshold and you owe the full package. Automatic sprinklers throughout, secondary water supply, standby and emergency power, a fire command center, an emergency voice and alarm communication system, and pressurized stair enclosures. Architects miss the trigger because they measure to the roof or the parapet rather than to the highest occupied floor. Atrium under Section 404 triggers on any opening through 2 or more stories that isn't a stair, elevator, or shaft. The package adds mechanical smoke control, full sprinklers, fire alarm, and a 1-hour separation between the atrium and adjacent spaces or fully sprinklered glass walls as the alternative. Covered mall under Section 402 triggers on the covered pedestrian zone connecting anchor stores. The package is sprinklers throughout, a special egress regime, and a 200-foot exit travel distance cap from any point in the mall. Misclassify a project, and the inspector forces the redesign. The single most important number in special occupancy work is the high-rise trigger height. 75 feet. Memorize the number and memorize the two ends of the measurement, because the trap is in the geometry, not the threshold. The bottom end is the lowest level of fire department vehicle access, not grade, not the lowest occupied floor. If the fire truck can drive up to a lower elevation around the back of the site, that lower elevation governs, and the 75 feet is measured upward from there. The top end is the highest occupied story, not the roof, not the parapet, not an equipment penthouse, and not a parking deck. Architects miscount and place the trigger at the roof, which is wrong and gets the question wrong on the exam. Pass the threshold by even a single foot, and you owe the entire high-rise package: sprinklers throughout, standby power, fire command center, voice alarm, and pressurized stairs. Cost-wise, crossing 75 feet by 1 foot can add millions to a project, which is why architects pull the top occupied floor down by a foot or two on borderline schemes rather than triggering the package. The required high-rise package itself is the easiest part to memorize once the trigger is settled. 5 items make up the high-rise package. 1 Section 403 applies, and each one is a separate cost line in the project budget. First, automatic sprinklers throughout, designed to NFPA 13, not the lighter 13R standard used in low-rise residential. The full standard is required because high-rise evacuation is slow, and the sprinkler system has to hold the fire alone for longer. Second, a secondary water supply that keeps sprinklers running if the primary city main fails or is cut off. Third, a fire command center on the first floor or an approved alternate location, equipped with the annunciator panels, communications, and controls the fire department needs to manage the incident. Fourth, an emergency voice and alarm communication system that lets the fire department deliver phased evacuation instructions floor by floor. And fifth, stairway pressurization or smoke-proof enclosure on every exit stair, positive pressure or a vestibule design that keeps smoke out of the egress route. Skip any one of these on a high-rise permit set, and the building official will reject the package, and you'll lose the schedule. Walk away with these 5 takeaways, and the special occupancy chapters become navigable on any complex project. 5 takeaways from the special occupancy chapters. First, the high-rise trigger is 75 feet from the lowest fire department vehicle access to the highest occupied floor. Second, the atrium trigger is any opening through 2 or more stories that is not a stair, an elevator, or a shaft. Third, the covered mall trigger is the covered pedestrian zone that links anchor stores. Fourth, the high-rise package layers 5 mandatory items: sprinklers throughout, standby power, a fire command center, an emergency voice alarm, and pressurized stair enclosures, and skipping any one of them fails the permit. And fifth, measure the trigger carefully on every project, because roofs, parapets, equipment penthouses, and parking decks do not count toward the highest occupied floor. Sprinklers are not interchangeable, and assuming they are is one of the most expensive mistakes a project can make. The IBC references 3 NFPA standards: 13, 13R, and 13D, and each one covers a different scope, applies to a different building type, and unlocks a different set of code bonuses. Confuse them on a permit set, and you either overspend by hundreds of thousands of dollars, or, worse, claim bonuses you have not earned and have to redesign the building when the inspector catches it. Fail the exam question on this distinction, and you lose the point. Miss it in practice, and the building official issues a stop work order, while the firm absorbs the fee shortfall. The 3 standards live side by side, and the comparison is the single most tested table in this section. 3 NFPA standards, 3 coverage maps. NFPA 13 is the full coverage standard: commercial, institutional, high-rise, including concealed spaces, mechanical rooms, attics, closets, and bathrooms. Because it covers everything, it unlocks the full set of IBC bonuses: higher allowable height, higher allowable area, longer travel distances, and reduced egress widths. NFPA 13R is the residential standard for buildings up to 4 stories. It covers dwelling units and common corridors but exempts attics, closets smaller than 24 square feet, and small bathrooms. Because the coverage is partial, the code bonuses are partial. Some height and area relief, but nowhere near the NFPA 13 package. NFPA 13D is the 1 and 2 family dwelling standard, covering living areas only, not garages, attics, or closets. It is primarily a life safety system for occupants, not a building bonus tool. Architects who specify 13R on a 4-story apartment, thinking they get the same bonuses as 13, are setting up a redesign when the IBC tables get applied correctly. The differential between NFPA 13 and 13R is the single most tested distinction on the exam. The differential between NFPA 13 and NFPA 13R is the most consequential question architects answer on residential and mixed-use projects. NFPA 13 covers every space in the building, including concealed spaces above ceilings, mechanical rooms, attics, closets, and bathrooms, regardless of size. Because coverage is complete, the IBC grants the full bonus package: higher allowable height per Table 504, higher allowable area per Table 506, and travel distance limits that typically climb from 200 feet to 250 feet. NFPA 13R covers only dwelling units and common corridors. Attics are exempt. Closets under 24 square feet are exempt. Small bathrooms under 55 square feet are exempt. Because coverage is partial, the bonuses are partial, and you must verify each bonus row by row against the IBC tables, rather than assuming parity with NFPA 13. The 4-story cap on NFPA 13R is the most common trap. An architect designs a 5-story R2 apartment thinking 13R applies, only to be told at planner view that anything over 4 stories requires 13, and the project blows its budget overnight. Beyond what unlocks bonuses, the IBC also lists occupancies where sprinklers are not optional. 6 occupancies trigger mandatory sprinklers under Section 903.2. Group A assembly triggers at occupant load over 300 or fire area over 12,000 square feet, whichever comes first. Group E educational triggers at 12,000 square feet of fire area, the threshold that catches every modern elementary and middle school. Group F, 1, moderate hazard factory triggers at the same 12,000 square foot fire area. Group H, high hazard is universal, requiring sprinklers regardless of size because the hazard itself drives the rule. Group I, institutional, covers nursing homes, hospitals, and jails, all of which require sprinklers throughout. Group R, residential, covers apartments, hotels, and dormitories, all requiring sprinklers per Section 903.2.8. Memorize these 6, and most exam questions on the topic answer themselves. Walk away with these 5 anchors so the sprinkler standard choice never slips on a permit set. 5 anchors from the sprinkler system framework. First, NFPA 13 covers everything in the building and unlocks the full IBC bonus package: taller, larger, longer travel distance, narrower egress. Second, NFPA 13R covers residential up to 4 stories, dwelling units and corridors, and grants only partial bonuses. Verify row by row against the tables rather than assuming parity. Third, NFPA 13D applies to 1 and 2 family dwellings and is fundamentally a life safety standard with minimal bonus rights. Fourth, specifying the wrong standard means claiming bonuses the building has not earned, and that mistake fails the permit set when the inspector catches it. And fifth, Section 903.2 enumerates 6 occupancies where sprinklers are mandatory: Group A, over 300 occupants or 12,000 square feet. Group E, Group F1, and any Group H, I, or R occupancy. And that list answers most exam questions on this topic. Most architects assume a fire alarm is a single product they specify and forget. It is not. It is a system, and the IBC tells you when the system is required, what initiation devices it must include, what notification appliances must accompany them, and which occupancies trigger automatic detection on top of the manual pull station baseline. Section 907 governs the rules, and NFPA 72 governs the installation. Get the trigger wrong, and you either overspend on coverage no occupancy needs, or you skip a system the inspector demands, and the permit set is rejected. Miss this on the exam, and you fail the question. Miss it in practice, and the project gets sued by an injured occupant. Or, worse, the firm loses its license over an ADA complaint when visual strobes were never installed. The trigger thresholds vary by occupancy, and a short table covers the 6 groups that show up on the exam. 6 occupancies. 6 different ways to land in a fire alarm requirement. Group A assembly triggers at occupant load over 300, and the package is straightforward. Manual pull stations at every required exit, nothing more. Group B business is the trap, and it is a 2-headed trigger. The first head is occupant load over 500. The second head fires in any building over 3 stories tall when occupant load above or below the level of exit discharge exceeds 100. A 4-story office building with 120 occupants on the 3rd floor needs an alarm even though total building occupancy is well under 500. Architects miss the second head constantly. Group E educational triggers at occupant load over 50 and adds corridor smoke detectors on top of the pull stations. Group 1 institutional is universal. Every nursing home, every hospital, every jail, and demands automatic detection plus manual pulls plus visual notification because occupants cannot self-evacuate. Group R1 hotels and Group R2 apartments are also universal, with R2 jumping from unit-level smoke alarms to a full building system once the project crosses 16 units. The system has 2 distinct halves, initiation and notification, and the IBC requires both. The initiation side is how the system finds out something is wrong, and it splits into manual and automatic. Manual is the pull station, at every required exit, mounted within 5 feet of the door per NFPA 72. Automatic is the smoke detector for corridors and lobbies, the heat detector for mechanical rooms and kitchens where smoke detectors would false alarm constantly, and the duct detector inside supply air handlers moving over 2,000 cubic feet per minute. The notification side is how the system tells occupants to leave. Audible is the temporal 3-horn or speaker, sized to clear ambient noise in every space. Visual is the strobe, and it carries its own scoping rule under ADA, required wherever audible is required, candela rating matched to room size, mounted at the right height. Voice evacuation comes on top of audible in high-rise, large assembly, and any building running phased evacuation rather than a single full building dump. Spec the initiation devices and forget the notification appliances, and the system has nothing to do. Spec audible without visual, and the building fails ADA. Visual notification is where most schematic design alarm packages quietly fail compliance review. 6 anchors for visual notification, and the first 3 answer most exam questions on the topic. First, every public use space that has audible coverage also needs visual coverage. Lobbies, corridors, restrooms, conference rooms, training rooms, all of it. Second, common use spaces in residential and mixed-use buildings extend the same rule. Laundry rooms, mail rooms, fitness rooms, leasing offices, package lockers, anywhere a resident might be alone when the horn sounds. Third, hotels and dorms must deliver full, visible alarm features in at least 2% of guest rooms, never less than 1 room, and the room types must include accessible suites. Fourth, and this is where architects lose ADA points on plan review, employee work areas need visual notification too, not only the public-facing spaces, whenever the building fire alarm system reaches them. Fifth, single-occupant rooms like restrooms and mother's rooms need strobes because a deaf occupant inside cannot hear the horn through a closed door. Sixth, candela ratings scale with room size. A 15 candela strobe covers a small office. A 180 candela strobe covers a large open floor. And the wrong rating fails the listed light distribution test even with the right count of devices. Walk away with this as the alarm system checklist for any code-driven schematic review. 5 anchors from the fire alarm framework. First, Section 907 of the IBC tells you when the system is required, and NFPA 72 tells you how to install it. Both documents live on the same job. Second, Group B business carries a 2-headed trigger that catches architects again and again. Occupant load over 500 or occupant load over 100 above or below the level of exit discharge in any building over 3 stories. Third, Group 1 institutional, R1 hotels, and R2 apartments trigger universally, regardless of size. For I occupancies, the package adds automatic detection on top of manual pulls. Fourth, the system has 2 halves. Initiation finds the fire through pull stations, smoke detectors, heat detectors, and duct detectors. Notification clears the building through horns and visual strobes. And skipping either half breaks the certification. And fifth, visual strobes are scoped to room size by candela rating, are required wherever audible is required, and reach public use, common use, and employee work areas alike. Walk a permit set in front of any plan reviewer, and the first red lines land on the fire resistance schedule. Every architect who has been through plan review knows this. The IBC uses 6 different rated assemblies to compartmentalize buildings: firewalls, fire barriers, fire partitions, smoke barriers, smoke partitions, and horizontal assemblies. And each one carries a different purpose, a different required rating, and a different rule about structural independence and continuity. Most architects use the words interchangeably in schematic design narratives, and the words are not interchangeable. The IBC codifies them in Chapter 7, section by section, and the exam writes a question every cycle that depends on knowing which one applies where. Confuse the terms, and you fail the exam question. In practice, the wrong assembly gets built, an occupant gets injured, and the firm gets sued for the call. 6 assembly types fit on one table, and the table is the foundation for every fire-rated detail in the building. 6 rows, 6 different sections of Chapter 7. Firewalls under Section 706 do the heaviest job. They divide a single building into 2 legally separate structures, run 2 to 4 hours, and must be structurally independent. Fire barriers under Section 707 do the workhorse separation duties, separating occupancies under the mixed occupancy rules, enclosing exit stairs, enclosing shafts, and run 1 to 2 hours without structural independence requirements. Fire partitions under Section 708 separate dwelling units, corridors, and tenant suites at 1 hour typical. Smoke barriers under Section 709 run 1 hour and resist smoke passage between compartments, which is different from resisting fire. Smoke partitions under Section 710 carry a 0-hour fire rating but still must resist smoke passage at a lower threshold. And horizontal assemblies under Section 711 are the floors and ceilings between stories, running 1 to 2 hours depending on construction type per Table 601. Match the assembly to the job, and the rating falls out of the table. The one rule that separates a firewall from every other assembly is structural independence, and it is worth its own definition. A firewall is the most demanding fire resistance assembly in the code, and the demand is structural. Per Section 706.2, the wall must extend continuously from foundation to roof, and per Section 706.5, it must be constructed so the collapse of the structure on one side will not bring the wall down with it. That is the defining test. A fire barrier supported by the surrounding building structure is not a firewall. It is a fire barrier, even at the same hourly rating, because it would collapse when its supports collapsed. The consequence of meeting the firewall standard is that the IBC treats each side as an independent building for height, allowable area, and construction type calculations. Two 30,000 square foot fire areas separated by a true 4-hour firewall are not one 60,000 square foot building under the area tables. They are two 30,000 square foot buildings, and that distinction can save an entire project from a redesign. Get the construction wrong, and the building official reclassifies the separation as a fire barrier, and the area calculation collapses with it. Side by side, the difference between wall and barrier is sharp, and the exam reaches for that difference every cycle. Both assemblies can carry a 2-hour rating, and that surface similarity is what makes the confusion costly. A firewall under Section 706 runs continuously from foundation to roof with no interruptions, stands structurally independent of the buildings on either side, and creates two separate code buildings for purposes of area and height. The price is the construction detail: heavy framing, masonry or concrete cores, robust parapets at the roofline, and detailing that survives partial collapse of the surrounding structure. The use cases are building separation in very large projects, row house party walls, and any case where the architect needs to break a single mass into smaller, calculable buildings. A fire barrier under Section 707 also runs continuous through concealed spaces, but the continuity stops at structural independence. The barrier is tied to and supported by the building's primary structure, which means if the structure on one side fails, the barrier fails with it. The building stays a single code building. Use cases are mixed occupancy separations under Section 508.4, exit stair enclosures and shaft enclosures. Same rating, different rule, completely different detail. 5 anchors close out the fire resistance framework for any schematic design review. 5 takeaways from the fire resistance framework. First, Chapter 7 of the IBC codifies 6 assembly types: firewalls, fire barriers, fire partitions, smoke barriers, smoke partitions, and horizontal assemblies, and each lives in its own section with its own rules. Second, firewalls under Section 706 are the only assembly that must be structurally independent, and that independence is what lets the code treat each side as a separate building for area and height calculations. Third, fire barriers under Section 707 carry the same hourly ratings as firewalls in many cases, but are not structurally independent, so they do not unlock the separate building math. Fourth, opening protectives, doors, windows, dampers, are rated at roughly 75% of the wall they sit in, so a 2-hour fire barrier takes a 1.5-hour door, and a 1-hour fire barrier takes a 45-minute door. And fifth, the words wall, barrier, and partition are not synonyms in the IBC. Match the assembly to the function you need it to perform, and the rating and the detailing follow. Most architects underestimate how aggressive the smoke problem really is, and you cannot fix it later. Smoke kills more occupants in fires than the flames themselves. That single fact drives 2 parallel chapters of the IBC. Section 909 governs active smoke control systems for the geometries where smoke cannot dissipate naturally, and Section 716 governs the opening protectives that keep rated walls from leaking smoke through the doors, windows, and ducts that penetrate them. The architect's job in schematic design is to identify which smoke control triggers apply, spec the right system type for each, and then carry the assembly rating through every opening in every rated wall, so the plan reviewer never has to send back a red line. Miss either step, and you fail the exam question. In practice, the building leaks smoke down the egress path during the exact minutes occupants need it clear, and the firm gets sued for the deaths that follow. 5 conditions trigger an active smoke control requirement, and the IBC names them by section. 5 triggers, 5 different system types. Atrium designs under Section 404 need mechanical smoke exhaust sized to keep the volume tenable during evacuation. Without it, the smoke layer descends to head height and the egress routes become impassable. High-rise stairways under Section 403 need stair pressurization, where supply fans push positive pressure into the stair shaft so that smoke cannot enter when doors are opened during evacuation. Underground buildings under Section 405 trigger when the lowest level sits more than 60 feet below the level of exit discharge, and the response is mechanical smoke exhaust. Natural ventilation cannot reach that depth. Covered malls under Section 402 take either smoke control or natural ventilation, depending on mall volume and roof configuration. Stages over 1,000 square feet under Section 410 demand smoke exhaust or proscenium venting because the fly loft above the stage is a chimney waiting to feed smoke into the audience. Match the trigger to the system on the schematic narrative, and the MEP engineer gets a clean handoff. Once the system is sized, every opening in every rated wall has to maintain the wall's job, and the IBC scales the rating down with a simple rule. Opening protectives track the wall rating at roughly 75%. That is the pattern to memorize. A 2-hour fire barrier takes a 1.5-hour door and a 1.5-hour fire window. A 1-hour fire barrier or partition takes a 45-minute door and a 45-minute window. A half-hour corridor wall takes a 20-minute door and a 20-minute window. The pattern breaks at the top of the table. 3-hour and 4-hour firewalls both take 3-hour doors because no commercially listed door exceeds that rating, and neither allows fire windows at all. The openings shrink to doors only, and even the doors are tightly scoped. This is the most cited table in Section 716, and the exam reaches for it directly. Specify a 2-hour barrier and a 60-minute door, and the inspector flags the door for failing the assembly. Specify a fire window in a 4-hour firewall, and the plan reviewer rejects the whole detail. Doors and windows are not the only openings. Ducts get their own damper rules, and the rules turn on which barrier the duct crosses. 6 anchors for damper specification, and the first 3 answer most questions on the exam. First, fire dampers go anywhere a duct penetrates a fire-rated assembly. That means walls, barriers, partitions, and horizontal floor-ceiling assemblies. The damper's job is to spring shut when fusible links melt and prevent fire from following the duct into the next compartment. Second, smoke dampers go anywhere a duct penetrates a smoke barrier or smoke partition. The damper is triggered by the building's smoke detection system rather than by a fusible link, because smoke moves faster than the heat needed to melt the link. Third, when the same assembly serves both functions, a 1-hour smoke barrier that is also fire-rated, the duct gets a combination fire-smoke damper, listed for both duties. Fourth, the damper rating must match the wall. 1.5-hour dampers in 1-hour walls, 3-hour dampers in 2-hour and greater walls. Fifth, ducts that penetrate rated floor-ceiling assemblies need ceiling radiation dampers, a separate listed product class. And sixth, every damper needs an access panel for inspection and manual reset, which means coordinating the ceiling plan with the mechanical drawings before drywall closes the assembly. Walk away with the smoke control framework as a unified rule set, not 5 disconnected sections. 5 takeaways from smoke control and opening protectives. First, the IBC names 5 conditions that trigger active smoke control: atriums, high-rise stairways, underground buildings over 60 feet below grade, covered malls, and stages over 1,000 square feet. And each one routes to a specific system type. Second, high-rise stairways use pressurization to keep smoke out of the stair, while atrium designs use mechanical exhaust to keep smoke off the egress floor. Third, opening protectives in rated walls track the wall rating at about 75%. 2-hour walls take 1.5-hour doors, with the exception that 3-hour and 4-hour firewalls forbid fire windows entirely. Fourth, damper specification follows the assembly the duct crosses. Fire dampers for fire-rated assemblies, smoke dampers for smoke barriers, combination dampers when the assembly carries both ratings. And fifth, every damper needs an access panel, which means coordinating ceilings and MEP during schematic design, rather than discovering the conflict during construction administration. Most architects walk into a renovation review and ask where the areas of refuge belong before they have checked whether any are required at all. You need to flip that order. Areas of refuge are protected waiting zones where people with disabilities, wheelchair users, anyone who cannot self-evacuate downstairs, can wait safely for assistance during a fire. Section 1009 of the IBC governs the rule, and the rule is straightforward on the requirement side and surprisingly narrow on the trigger side. The biggest exemption is sprinklered buildings, and since most modern commercial buildings are fully sprinklered under NFPA 13, the requirement bites mostly on older buildings and renovations. Miss the exemption, and you specify equipment the building does not need, eating into the fee. Miss the actual requirement, and the building official rejects the permit set. Or worse, a disability rights lawsuit hits the firm for an ADA violation the architect should have caught at design. When a refuge is required, 6 baseline requirements define what it has to deliver. 6 requirements define a compliant area of refuge. First, location. The refuge sits adjacent to an exit stairway on every floor above or below the level of exit discharge, because the stair is where rescue arrives. Second, size. Minimum 30 inches by 48 inches for each wheelchair space, scaled at 1 wheelchair space per 200 occupant load on the floor, never less than 1. Third, protection. The refuge sits either inside the exit stair enclosure itself or in an area separated from the building by a 1-hour smoke barrier, because the whole point is keeping smoke off the occupant while they wait. Fourth, communication. A 2-way voice system to the fire command center or to 911, so the occupant can tell rescuers exactly where they are. Fifth, signage. Tactile signage at the door and visual signage on the wall identifying the area as a refuge. Sixth, ventilation. Direct access to outside air if the refuge is a separated space, so the occupant is not trapped in a sealed box. Skip any one of these and the inspector cites the refuge as non-compliant. The firm has to retrofit before the certificate of occupancy is issued. But before designing the refuge, check whether the building has already exempted itself. 5 exemptions, and the first one dwarfs the others in real-world impact. First, any building fully protected by an NFPA 13 sprinkler system is exempt. And since NFPA 13 is the default for commercial, institutional, and most modern multifamily projects, this exemption sweeps the majority of new construction off the refuge requirement entirely. Second, buildings with a supervised automatic sprinkler system plus an emergency voice and alarm system are exempt, which covers most high-rise designs. Third, open parking garages are exempt because their open construction means smoke does not accumulate. Fourth, buildings where every floor has an accessible exit discharged directly to grade are exempt, typical of low-rise residential where every unit has a ground-level door. Fifth, floors with a horizontal exit that leads to an accessible means of egress are exempt because the horizontal exit is itself a refuge. Most architects assume refuge spaces are universally required and waste design fees specifying them. You check the exemption list first. The dominance of the sprinkler exemption is worth a single number. 1. That is the wheelchair space count per 200 occupant load on the floor, and it is the sizing rule that drops out of Section 1009.6.2 whenever a refuge is required at all. The number sounds small until you walk a hospital floor and realize that a 120-bed unit with visitors and staff cranks out an occupant load well over 400, which means at least 2 wheelchair spaces per floor, every floor. The sprinkler exemption under Section 1009.3 is what saves most modern projects from the calculation entirely, because once an NFPA 13 system covers the building, the refuge requirement evaporates. The architects who keep specifying refuge spaces in fully sprinklered offices are over-designing and eating fee. The architects who skip refuge spaces in a renovation of an unsprinklered older office building are setting the firm up for an ADA lawsuit when an occupant with mobility limitations gets injured trying to exit during an alarm. Either way, you check the exemption list first. 5 anchors close out the Areas of Refuge framework. 5 takeaways from the Areas of Refuge framework. First, when a refuge is required, it lives adjacent to an exit stair, sized at 30 by 48 inches per wheelchair space, at 1 space per 200 occupant load. Second, two-way communication to the Fire Command Center or to 911 is mandatory. Without it, the refuge is non-functional because rescuers cannot find the occupant. Third, tactile signage at the door and visual signage on the wall identify the refuge on every floor. Missing signage is the most common inspector citation. Fourth, the NFPA 13 sprinkler exemption under Section 1009.3 is the dominant real-world exception and removes the refuge requirement from most new commercial and multifamily construction. And fifth, the requirement bites primarily on unsprinklered older buildings and on historic renovations where adding a refuge is part of the accessibility upgrade scope. Most architects equate exits with stairs, and most exit count failures on a permit set come from that single assumption. You can exit a building horizontally through a firewall into a separated compartment. Or you can extend an exit stair to a distant exterior door through a fire-rated passageway. And both moves count as legitimate exits under the IBC. Section 1026 governs the horizontal exit, and Section 1024 governs the exit passageway, and the two are not the same thing. Confusing them on a hospital permit set is one of the most expensive mistakes in I-2 design, because hospitals depend on horizontal exits to move bedridden patients to safety. Fail to grasp the distinction on the exam, and you lose the question. In practice, the firm fails the I-2 plan review, the schedule slips, and the owner sues for redesign cost. The horizontal exit has 6 requirements that the IBC names explicitly. 6 requirements turn a firewall into a legitimate horizontal exit. First, the definition. A horizontal exit is a firewall that divides a single building into 2 separate fire compartments, with the wall meeting the structural independence test under Section 706. Second, the rating. 2 hours in a non-sprinklered building with a reduction to fire barrier rating allowed when the building is fully sprinklered. Third, the capacity. The refuge area on the non-fire side must accommodate occupants from both sides of the wall, because everyone who passes through the door joins the people who were already on the safe side. Fourth, the limitation. A horizontal exit cannot serve more than 50% of a floor's total exit capacity, which means at least half the exits must still be vertical stairs or direct exterior doors. Fifth, doors. Self-closing and swinging in the direction of egress travel, so the wall stays sealed when no one is moving through. And sixth, refuge area. Minimum 3 square feet per occupant on the non-fire side, computed for the combined load, including the occupants who already lived in that compartment. Miss the 50% rule, and the inspector reclassifies the exit. Suddenly, the floor is short on egress capacity, and the plan reviewer rejects it. Exit passageways operate on a parallel but distinct rule set. 4 rules define an exit passageway. First, the definition. A passageway is a fire-rated horizontal corridor that connects an exit stair to the exit discharge, or that extends an exit out to the building exterior. The passageway is itself part of the exit, not an exit access path. Second, the rating. The passageway carries the same rating as the stair enclosure it serves, so a 1-hour stair becomes a 1-hour passageway, and a 2-hour stair becomes a 2-hour passageway. Third, the use case. Passageways exist primarily to route an interior discharging stair to a distant exterior door, which is common in large floor plates where the stair lands in the building's interior. Fourth, the limitation. No openings are permitted in the passageway walls except exit doors, doors for equipment serving the passageway itself, and doors providing egress from adjoining spaces. Punch a tenant door into a passageway wall, and you have invalidated the passageway, and the exit stair no longer counts. The architects who confuse refuge area, horizontal exit, and exit passageway lose exam points on every cycle. The refuge area inside a horizontal exit and the exit passageway look similar on a floor plan. Both are fire-rated spaces, but they do completely different jobs. A refuge area is a destination. The occupant walks through the 2-hour firewall and stops, waiting on the safe side of the compartment until conditions allow further evacuation or until rescuers arrive. The square footage rule of 3 square feet per occupant of combined load reflects that role. The space must hold people, not just route them. An exit passageway is a conduit. The occupant walks through it on the way to discharge, never stopping. The rating matches the stair enclosure rather than the compartment separation logic. Mix the two on a hospital permit set, and you either oversize the passageway, wasting square footage, or undersize the refuge area, putting bedridden patients at risk during evacuation. The IBC tests the distinction directly, and the firm that gets it wrong loses both the exam point and the I-2 design. Walk away with 5 anchors, so the horizontal egress paths stay distinct. 5 anchors from the horizontal exits and passageways framework. First, a horizontal exit is itself a 2-hour firewall that divides the building into 2 separate fire compartments, and the wall must meet the structural independence test of Section 706 to qualify. Second, a horizontal exit cannot serve more than 50% of a floor's total exit capacity, which means at least half the exits must still be vertical stairs or direct exterior doors. Third, the refuge area on the non-fire side must hold occupants from both sides combined at 3 square feet per occupant, with self-closing doors swinging in the direction of egress travel. Fourth, an exit passageway is a fire-rated horizontal corridor that extends an exit stair to a distant exterior door, carrying the same rating as the stair enclosure, with no openings except those serving the passageway itself. And fifth, hospitals and other I-2 occupancies depend on horizontal exits because bedridden patients cannot use stairs. Get the rule wrong on an I-2 design, and the project fails plan review, and the firm absorbs the redesign. Most architects know the 75-foot threshold, and you probably memorized it for the foundational exam. What gets you in advanced practice is everything that descends on the project the moment you cross it. Section 403 of the IBC does not add one requirement. It adds an entire package: smoke-proof enclosures, emergency voice and alarm, luminous egress path markings, fire service access elevators, stairway identification signage, and stairway door re-entry rules. Pass the threshold by 1 foot and you owe every line item. Miss any of them on the permit set and the plan reviewer rejects the package. The firm absorbs the redesign cost, or worse, an occupant gets injured during evacuation and the firm gets sued for negligent design. The trigger height is the single most important number in the whole framework. 75 feet. The number itself is easy to remember. The geometry of the measurement is what trips most architects up on exam day. The bottom end is the lowest level of fire department vehicle access, not grade, and not the lowest occupied floor. If a fire truck can drive up to a lower elevation around the back of the site, that lower elevation governs. The top end is the highest occupied story, not the roof, not the parapet, not an equipment penthouse, not the top of a parking garage. Architects miscount the top and get the question wrong on the exam. In practice, projects sit 1 foot above the trigger because the architect did not pull the top occupied floor down during schematic design, and the high-rise package adds millions to the construction cost. Most architects on borderline schemes drop the top floor by a foot or two specifically to stay under the threshold because the package is that expensive. Once the threshold is crossed, 5 additional egress requirements apply. 5 requirements descend together. First, smoke-proof enclosures. Every exit stair becomes a pressurized stair or gets a vestibule approach, so positive pressure inside the stair shaft keeps smoke from entering during an evacuation. Second, emergency voice and alarm. Speakers in stairs, elevators, corridors, and common spaces so the fire command center can direct phased evacuation rather than dumping everyone into the stairs simultaneously. Third, luminous egress path markings. Photoluminescent stripes on stair nosings, on handrails, on landings, and on obstacles, so occupants can follow the egress path in total darkness if normal lighting and emergency lighting both fail. Fourth, a fire service access elevator with standby power, water protection, and a protected lobby. This is how firefighters reach the fire floor without climbing 40 stories of stairs. Fifth, stairway identification signage on every stairside landing. Floor number, stair designation, roof access information, and clear text about which floors allow re-entry from the stair. 5 separate subsections of Section 403. All 5 apply the moment you cross the trigger. Stairway door re-entry is the rule that saves lives, and it has its own design choice. 4 anchors define the stairway door re-entry rule, and the design choice is binary. First, the selective option. At least every 4th floor must allow re-entry from the stair side back to the floor, per Section 403.5.3 of the IBC. The other floors lock from the stair side for tenant security reasons. Second, the universal option. All stair doors throughout the building remain unlocked from the stair side, eliminating the issue at the cost of tenant-level lockout discipline. Third, the reason behind the rule. If an evacuating occupant enters the stair and discovers their destination floor is blocked by fire or smoke, they cannot be trapped in the shaft. They need a way back into a different floor. Older buildings without re-entry rules killed people during high-rise fires because evacuees could not exit the stair on any floor and got caught between smoke layers. Fourth, signage. Every door must carry clear text indicating whether re-entry from the stair is allowed on that floor, and signage failures are one of the most common stairside inspection citations. Walk away with the high-rise package as a single, triggered bundle. 5 takeaways from the high-rise egress framework. First, the 75-foot trigger is measured from the lowest level of fire department vehicle access up to the floor surface of the highest occupied story, and the geometry of the measurement is what most architects get wrong. Second, 5 separate egress requirements descend together once the trigger is crossed: smoke-proof enclosures, emergency voice and alarm, luminous egress markings, fire service access elevators, and stairway identification signs, none of them optional. Third, smoke-proof enclosures use stair pressurization or a vestibule approach to keep smoke out of the exit stair during evacuation. Fourth, stairway door re-entry is a binary design choice. Either at least every 4th floor allows re-entry, or all stair doors throughout the building unlock from the stair side. And fifth, phased evacuation via the voice alarm system prevents stairway congestion in tall buildings. Fire floor occupants evacuate first, then the floors immediately above and below, then everyone else as the command center directs. Most architects treat emergency lighting and exit signs as a single line item. And you can see why on a permit set. Both run on backup power, both activate when normal power fails, and both serve the same egress path. They are still two different systems doing two different jobs. Emergency lighting illuminates the path so occupants can see where they are walking. Exit signs identify the destination so occupants know where they are walking to. Confuse them and you spec only one, leaving the building partially blind during an evacuation. Section 1008 governs the lighting, and Section 1013 governs the signage, and a single failure on either trips a code violation that puts evacuating occupants at risk that translates directly into negligence lawsuits when occupants get injured trying to find an exit they cannot see. Emergency lighting carries 5 specifications under Section 1008. 5 specifications define emergency lighting. First, the coverage map, required throughout exit access corridors, exit stairways, exit passageways, and exit discharge areas. Anywhere occupants travel as part of the egress path, emergency lighting is required. Second, the illumination level, 1 foot candle average along the path, with a minimum of 1/10 of a foot candle at any single point. The minimum point matters because the path of egress lighting cannot have dark spots. The inspector measures with a foot candle meter. Third, the duration, 90 minutes minimum on battery backup or generator power, because that is the worst case evacuation window the IBC accepts. Fourth, the activation, automatic the moment normal lighting fails, with no occupant action required. Switching from grid power to battery power must be instant. Fifth, the exception list, dwelling units, sleeping units, group use storage, and aisle accessways in Group A occupancies, the last of which is reduced to 2/10 of a foot candle for assembly spaces where lower light levels are part of the experience. Exit signs add 6 specifications under Section 1013. 6 specifications define exit signs. First, location. Every exit door gets a sign, and so does every point along the exit access path where the exit itself is not readily visible. The rule is functional. If an occupant standing at any point in the path cannot see the exit door, a sign with a directional arrow must be visible. Second, visibility distance. The sign must be readable from 100 feet, which drives both size and contrast. Third, illumination. Internally or externally illuminated, with 5 foot candles on the face of the sign. Self-luminous, photoluminescent options exist, but are subject to additional listing requirements. Fourth, power. Connected to emergency power with a minimum of 90 minutes of backup, matching the emergency lighting duration. Fifth, letter geometry. The word exit must appear in letters at least 6 inches tall with a stroke width of 3/4 of an inch, because smaller letters do not meet the 100-foot visibility test. Sixth, directional arrows. Required wherever the egress direction is not obvious from the door's position, and the arrow points toward the nearest exit, not in some abstract direction. Side by side, the two systems overlap in some attributes and diverge in others. Both systems share 3 attributes and differ on the photoluminescent rule. Both must cover the egress path throughout, lighting along the corridor and stair, signs at every door and decision point. Both must activate automatically the moment normal power fails. Both must run on backup power for at least 90 minutes. The divergence is on the photoluminescent question. Photoluminescent technology, paint and tape that absorbs ambient light during the day and glows during a power outage, is permitted by the IBC as a self-luminous exit sign, provided the sign is listed and charged by a reliable light source. That much is fine. The trap is in the lighting side. Photoluminescent stripes on stair nosings and handrails supplement emergency lighting, but do not replace it. Specify only photoluminescent markings on the egress path with no emergency lighting fixtures, and the building fails its lighting certification. The exam reaches for this distinction every cycle, and the firms that fail to make it in practice are the firms named in lawsuits when an injured occupant cannot find the exit during a real evacuation. Walk away with the 5 anchors that distinguish the two systems. 5 takeaways from the Emergency Lighting and Exit Signs Framework. First, the two systems do 2 different jobs. Emergency lighting illuminates the path so occupants can see where they are walking, and exit signs identify the destination so occupants know where they are walking to. Both required, neither optional. Second, the lighting standard is 1 foot candle average along the path with a minimum of 1/10, while the exit sign carries 5 foot candles on the face of the sign. Same egress path, different metrics. Third, both systems must run on 90 minutes of backup power with automatic activation the moment normal power fails. Fourth, exit signs must be visible from 100 feet with the word exit in 6-inch letters at 3/4 inch stroke width, plus directional arrows wherever the path is not obvious. And fifth, photoluminescent exit signs are explicitly permitted when listed and properly charged. But photoluminescent stripes on stair nosings supplement emergency lighting fixtures and never replace them. The architects who skip the lighting cite this exemption incorrectly. Most architects can quote the 2% figure for Type A units from memory and stop there. You cannot. The full accessibility scoping for multifamily housing runs across 3 documents: the IBC, ICCA 117.1, and the Fair Housing Act, and each one has its own threshold that triggers different obligations on different unit counts. Type A units are fully accessible from the day occupants move in. Type B units are adaptable, with the bones in place for future grab bars and base cabinet removal. The IBC scopes Type A at 2% in buildings with 20 or more units. The Fair Housing Act, separately, scopes Type B at every unit on every accessible floor in every building of 4 or more units. Miss the fair housing rule on a 6-unit walk-up, and the firm gets sued by HUD for an ADA and FHA violation. That lawsuit is one of the leading sources of professional liability claims in residential practice. Side by side, the 2 unit types serve different occupants in different ways. Type A units are fully accessible the day an occupant moves in. The kitchen has lowered counters, a roll-in shower or accessible tub, reinforced walls already in place, 32-inch clear doors throughout, and switches and outlets within accessible reach range on every wall. The occupant uses the unit out of the box. No modifications needed. Type B units are adaptable rather than accessible. The kitchen has standard counters, but the base cabinets under the sink are removable so that a wheelchair user can roll up to the sink when the unit is occupied by someone who needs that. The bathroom walls are reinforced behind the tub and the toilet so that grab bars can be installed without ripping out drywall. The primary entry is 32 inches clear so that a wheelchair fits through the front door. Other doors are adjustable when needed. Outlet placement is standard, with the understanding that future occupants will adapt as required. The Fair Housing Act drives the Type B scoping more than the IBC does, and that distinction is where most architects lose the lawsuit. 5 scoping rules cover the R2 building types in the IBC. 5 rows cover the scoping for R2 multifamily housing. First row. An elevator building with 20 or more units must include Type A at 2% of total units with a minimum of 1, plus Type B on the remaining 100%. So, a 100-unit apartment building delivers 2 Type A units and 98 Type B units. Second row. An elevator building with fewer than 20 units does not require any Type A units under the IBC, but every unit on every floor served by the elevator must still be Type B, because the elevator makes them all accessible from the entry. Third row. A walk-up building with 20 or more units requires Type A at 2% on the accessible level, typically the ground floor, with Type B on every ground floor unit. Fourth row. A walk-up with fewer than 20 units skips Type A entirely, but still requires Type B on every ground floor unit. Fifth row. R1 hotels carry a separate scoping table at 1107.6.1.1 and are not subject to the Type B regime at all. But the IBC is not the only statute in play, and the Fair Housing Act trigger is far lower. 4 units. That is the Fair Housing Act trigger, and unlike the IBC, there is no 20-unit escape clause hiding underneath it. Every multifamily building of 4 or more units constructed for first occupancy after March 13, 1991, must provide adaptable design features in every ground floor unit, or in every unit when the building is served by an elevator. A 4-unit walk-up in a small town is fully subject to FHA, the same as a 400-unit luxury tower. Most architects assume that small buildings escape the rule because they escape the IBC 20-unit threshold, and that assumption is the single most expensive mistake in residential practice. HUD enforces FHA, and complaints can result in compensatory damages, civil penalties, and injunctions requiring the building to be retrofitted at the developer's cost. Costs that the developer then turns around and sues the architect for under-professional liability. The post-occupancy FHA lawsuit is one of the leading claim categories in residential design errors and omissions. You read the FHA scoping every project, regardless of unit count. Walk away with the 5 anchors that keep the FHA risk visible. 5 takeaways from accessible dwelling units. First, Type A units are fully accessible the day the occupant moves in, with lowered kitchen counters and roll-in showers, while Type B units are adaptable with reinforced walls behind tub and toilet and removable base cabinets under the kitchen sink. Second, the IBC requires Type A at 2% of total units in R2 buildings of 20 or more units, with at least 1 Type A unit minimum, and 100% Type B on the rest. Third, buildings under 20 units skip the Type A requirement entirely, but still need Type B on every ground floor unit, or every unit when elevator served. Fourth, the Fair Housing Act applies separately to every multifamily building of 4 or more units constructed for first occupancy after March 1991, with no 20-unit escape. A 4-unit walk-up is fully subject. And fifth, post-occupancy Fair Housing Act lawsuits are one of the leading sources of professional liability claims against residential architects, which makes FHA scoping a non-negotiable schematic design checklist item. Most architects can describe a curb ramp's truncated dome surface, and you have probably specified them on a streetscape detail without thinking too hard about where they are required and where they are not. The 2 ADA rules that govern visual impairment hazards are Section 705 for detectable warnings and Section 307 for protruding objects. And both turn on the same geometry: the standard long cane sweep at 27 inches above the finished floor. Get the geometry wrong, and you place detectable warnings at building entries where they are not required, wasting fee. More dangerously, you mount a wall-hung drinking fountain 6 inches deep at 50 inches above the floor, and a blind occupant walking with a long cane hits it with their head because the cane swept under the fountain without touching it. That injury is a lawsuit waiting to be filed, and the architect of record is named in it. The cane detectable zone is worth a formal definition before the location rules. The cane detectable zone is the vertical band on every wall between 27 inches above the finished floor and 80 inches above the finished floor. And the ADA protects that band specifically because a long cane cannot reach into it. The cane sweeps the floor in an arc roughly 4 inches above the surface, so anything mounted below 27 inches gets struck by the cane before the user's body reaches it. Anything mounted above 80 inches passes over the user's head with clearance. The band between 27 to 80 inches is invisible to the cane and is exactly head height for a standing adult. Section 307 therefore prohibits any wall-mounted object in that band from protruding more than 4 inches from the wall surface. Mount a fire extinguisher cabinet 6 inches deep at 50 inches above the floor in a corridor, and the building fails ADA. The blind occupant walking that corridor with a cane will not detect the cabinet and will collide with it at head height. The injury is real, and so is the lawsuit. The detectable warning rule under Section 705 has 5 distinct location triggers. 5 locations cover the entire detectable warning rule, and 3 of them are required, while 2 are not. Required at curb ramps at street crossings, 24 inches deep in the direction of travel, and full width of the ramp, with the truncated dome surface in contrasting color. Required at transit platform boarding edges where rail vehicles approach, 24 inches deep along the full edge, typically painted yellow. Required around the perimeter of reflecting pools that lack a wall or railing, 24 inches wide around the pool. Not required at curb ramps inside parking lots. The 1991 ADAAG required them, but the 2010 standards removed that obligation. Not required at building entries or lobby thresholds, despite this being the most common misconception in detail set red lines. Spec detectable warnings at building entries, and you have added cost and confusion. Skip them at a street crossing, and you have set the project up for an ADA complaint and the resulting lawsuit. Protruding objects carry 4 limit rules that follow the cane sweep geometry. 4 conditions, 4 different protrusion limits. First, wall-mounted objects in the cane detectable zone, between 27 and 80 inches above the finished floor, cannot project more than 4 inches from the wall. That covers fire extinguisher cabinets, drinking fountains, wall-mounted signage, fold-down seats, surface-mounted controls, and decorative wall-mounted lighting. Second, wall-mounted objects below 27 inches have no protrusion limit because the cane sweep finds them before the user does. Lower-mounted artwork, baseboard heating, and base cabinets all sit below the zone. Third, post-mounted objects in the cane zone may project up to 12 inches from the post, but the accessible route width through that area must remain at 36 inches minimum. This rule covers wayfinding signage on posts, parking lot lighting, and street furniture fixtures. Fourth, overhead clearance must be at least 80 inches. Anything lower requires a barrier or guardrail at the ground level so the blind user's cane detects the hazard zone before they walk into it. Specify a low-hung wayfinding sign at 76 inches with no barrier underneath, and the inspector cites the corridor. An injured occupant ultimately sues. Walk away with 5 anchors that keep the cane zone geometry visible on every project. 5 anchors from the Detectable Warnings and Protruding Objects Framework. First, the cane detectable zone is the wall band between 27 inches and 80 inches above the finished floor. Below it, the cane sweeps and finds the object. Above it, the user passes under. Second, any wall-mounted object inside that zone cannot project more than 4 inches from the wall, which means fire extinguisher cabinets, drinking fountains, and surface-mounted controls must all be recessed or surface-mounted within the 4-inch limit. Third, detectable warnings under ADA Section 705 are required at curb ramps at street crossings, at transit platform boarding edges, and around reflecting pool perimeters when no wall or rail bounds the pool. Fourth, detectable warnings are explicitly not required at building entries and lobby thresholds under the 2010 standards, even though the 1991 standards required them at parking lot curb ramps. And fifth, overhead clearance for any accessible route must be at least 80 inches above the finished floor. Anything lower needs a barrier at floor level so the cane detects the hazard before the user collides with it. Most architects know there is an elevator exemption for small 2-story buildings, and you have probably leaned on it for a small commercial project. The exemption is narrow, and it is full of carve-outs that catch architects in practice and on the exam. The general rule is that buildings of fewer than 3 stories and fewer than 3,000 square feet per story can skip the elevator. The carve-outs strip that exemption away for shopping centers, professional offices of healthcare providers, and transportation terminals. 3 building types where vertical accessibility is non-negotiable. Design a 2-story medical office on the exemption, and the building official rejects the permit at the threshold. Design and build it that way without catching the error, and you face an ADA lawsuit from a patient who cannot reach the upper floor. 4 exemption conditions cover the elevator scoping landscape. 4 exemption conditions cover the landscape. First, the private sector exemption for buildings of fewer than 3 stories total. Carve-outs disable it for shopping centers, professional offices of healthcare providers, and transportation terminals. 3 building types where the exemption never applies, regardless of size. Second, the private sector exemption for buildings of less than 3,000 square feet per story. The same carve-outs apply. Third, a 2-story Group B office building can skip the elevator if the upper floor has no public function, no customer-facing services, no retail, no medical exam rooms. Add a customer-facing service anywhere on the upper floor and the exemption is gone. Fourth, mezzanines have their own scoping based on size and function. Aggregate mezzanine area above 3,000 square feet triggers the elevator requirement regardless of the base building exemption. The medical office trap is the one that gets architects in practice. They assume any small 2-story office qualifies, and the ADA immediately removes the exemption because the building is a healthcare facility. And there is a subtle and versus or discrepancy between the IBC and the ADA scoping. The IBC and the ADA both define an elevator exemption based on the same 2 parameters: story count under 3 and floor area under 3,000 square feet per story. But they connect those parameters with different logical operators. IBC section 1104.4 uses and. The building must be under 3 stories and under 3,000 square feet per story to skip the elevator. That is the more restrictive reading. ADA section 206.2.3 exception 1 uses or. The building must be under 3 stories or under 3,000 square feet per story. Either condition alone qualifies. That is the broader reading. A 4,000 square foot, 2-story office building is exempt under the ADA's or rule, but not under the IBC's and rule. Defer to the AHJ on which reading governs, because both texts apply simultaneously, and a permit fight over the discrepancy delays the project. Either way, both texts share the medical office, shopping center, and transit terminal carve-outs, so the carve-outs apply regardless of which rule the official is reading. When the elevator is required, 6 cab specifications govern the design. 6 anchors define the accessible elevator cab. First, minimum cab size: 80 inches deep by 54 inches wide for a side-opening elevator. A wheelchair plus an attendant must turn around inside that footprint, and tighter cabs fail certification. Second, door opening: 36 inches minimum clear width, fully retractable so the door does not encroach on the doorway. Third, call buttons in the hoistway lobby: maximum 42 inches above the floor with minimum 3/4 inch diameter to allow palm activation by users with limited grip strength. Fourth, controls inside the cab: the highest control button cannot sit more than 48 inches above the floor, which is the seated reach range from a wheelchair. Fifth, audible and visual indicators for floor arrival: the chime announces arrival to the visually impaired user, and the visual indicator announces it to the deaf user. Sixth, the door reopening device must detect objects between 5 and 29 inches above the floor, which covers wheelchair footrests, cane tips, and crouching children. Skip any one of these, and the elevator fails its ADA certification. The building does not get its certificate of occupancy, and the firm absorbs the rework. Walk away with the 5 anchors that keep the elevator scoping honest. 5 takeaways from the elevator framework. First, the under 3 stories exemption never applies to shopping centers, professional offices of healthcare providers, or transportation terminals. A 2-story medical office building must have an elevator regardless of footprint. Second, the IBC reads the exemption as an and rule, requiring both story count and floor area to be under threshold, while the ADA reads it as an or rule, where either condition alone suffices. Defer to the authority having jurisdiction on which text governs. Third, when an accessible elevator is required, the cab must measure at least 80 inches deep by 54 inches wide, with a 36-inch minimum clear door opening. Fourth, hoistway call buttons cannot sit more than 42 inches above the floor, and the highest cab control cannot exceed 48 inches, both heights matching seated wheelchair reach. And fifth, the door reopening device must detect objects between 5 and 29 inches above the floor, covering wheelchair footrests, cane tips, and crouching children. Most architects misread the historic preservation rule in ADA and the IBC. And you have probably heard a colleague say a historic building is exempt from accessibility. That is wrong. Historic buildings are not exempt from accessibility requirements. They receive flexibility in how the access is provided when strict compliance would threaten the building's historic significance. Layered on top of that misconception is the scoping for 2 specific assistive systems: assistive listening systems for the hearing impaired and visual alarms for the deaf, which most architects underspec because the scoping rules are buried in Section 216 and Section 702 rather than the main accessibility chapters. Skip the listening system in a courtroom, and the firm gets named in a discrimination lawsuit. Treat a historic building as exempt, and the same lawsuit lands faster. Assistive listening systems carry 3 location-specific scoping rules. 3 triggers cover assistive listening systems under Section 219 of the ADA. First, assembly areas with audio amplification. Auditoriums, theaters, lecture halls, places of worship must provide receivers for 25% of seating capacity, with international symbol signage at the point of entry indicating the system is available. 25% is the floor. Some jurisdictions push higher. Second, courtrooms, 50% of seating capacity, double the assembly threshold, because hearing testimony is the entire point of the proceeding, and witnesses and parties must follow it regardless of hearing ability. The signage must identify the type of system available so deaf users can select the appropriate receiver. Third, ticket windows with intercom systems. Every window must be accessible, with the international symbol at each window. The architects who underspec the listening system in a courthouse face an immediate ADA complaint when a hearing-impaired juror cannot follow testimony, and the lawsuit is sharp. Visual alarms split into 4 location-specific rules under Section 215. 4 visual alarm location triggers. First, public and common use areas, lobbies, corridors, restrooms, conference rooms get visual strobes connected to the building fire alarm. Second, hotel and dormitory guest rooms get visual notification appliances for the fire alarm, plus separate visual notification for door knock and telephone ring. The deaf occupant inside the room needs to know someone is at the door and the phone is ringing as much as they need to know the building is on fire. Third, at least 2% of hotel and dorm guest rooms must include full visible alarm features, including beds equipped with bed shaker devices for sleeping occupants, never less than 1 room, and the accessible rooms must span the available room types. Fourth, employee work areas need visual alarm coverage wherever the building fire alarm system reaches them. The mistake most architects make is treating visual alarms as a public spaces only rule and skipping the employee back-of-house areas. The inspector cites the omission and the firm pays for the retrofit. Historic buildings have their own accessibility regime, and it is more nuanced than most architects believe. 5 rules govern accessibility in historic buildings. First, full compliance is required to the maximum extent feasible. The starting point is the same standard that applies to any other building. Second, alternative methods are permitted only when strict compliance would threaten or destroy the building's historic significance. Narrow grounds, not a blanket pass. Third, consultation with the State Historic Preservation Office is required before any alternative method is approved, and the consultation must be documented in the design record. Fourth, common alternatives include accessible entry through a side or rear door when the main entry cannot be modified, ramps at secondary entrances, and platform lifts in lieu of full elevators. Fifth, historic status alone never excuses zero accessibility. A building cannot be declared too historic to be accessible at all. Some level of access must be provided. Architects who treat historic preservation rules as an exemption set the firm up for an ADA complaint, a discrimination lawsuit, and a public relations problem. The right approach is documenting the maximum feasible access analysis with the SHPO from day one of design. Walk away with 5 anchors that keep both assistive systems and historic building access defensible. 5 anchors from assistive systems and historic buildings. First, assistive listening systems must provide receivers for 25% of seating capacity in assembly areas with audio amplification and 50% in courtrooms, twice the baseline, because hearing testimony is the entire point of a courtroom. Second, visual alarms apply to public and common use areas, employee work areas wherever the fire alarm reaches, and hotel and dormitory guest rooms with strobes plus door knock and telephone ring notification. Third, at least 2% of hotel and dorm guest rooms must include full visible alarm features, including bed shaker devices, never less than 1 accessible room. Fourth, historic buildings receive flexibility in how accessibility is provided when strict compliance would threaten historic significance, not exemption from the accessibility obligation. And fifth, consultation with the State Historic Preservation Office is required before any alternative method is approved, and the consultation must be documented. Skip the SHPO step, and the alternative method is non-defensible if challenged. Most architects treat zoning as a checkbox at the front of schematic design. Verify the use is permitted, confirm the setbacks, move on. You cannot. Zoning runs on a track parallel to the IBC, and both must be fully satisfied before any permit is issued. The IBC asks whether the building is safe. Zoning asks whether the building belongs on the site. The two answers can diverge sharply. A 10-story Type 2A office building is allowed at 85 feet under the IBC with sprinkler bonuses. But if local zoning caps the parcel at 45 feet, zoning wins, and the project is half the size the IBC would permit. Miss the zoning constraint at design start, and you waste fee schemes that cannot be built, and the owner sues for the redesign cost. 6 zoning parameters drive that constraint, and each one shapes the design in a different way. The 6 parameters fit on a table that every project needs at kickoff. 6 parameters define what zoning will allow on the site, and you need all 6 before a single schematic line gets drawn. First, setbacks. The minimum distance from each property line to the nearest building face, with separate requirements at the front, sides, and rear. Tight setbacks shape the footprint directly. Second, height limit. Capped in feet or stories, often measured from average grade or street level, rather than from the lowest fire department access point used by the IBC, which is why the 2 height numbers rarely match. Third, floor area ratio, or FAR, the most powerful zoning lever, computed as total building floor area divided by lot area, with the result capping how much program can fit on the site. Fourth, lot coverage, the maximum percentage of the lot covered by the building footprint, which protects open space and stormwater management. Fifth, use classification, whether the site is zoned residential, commercial, industrial, or mixed use, and which specific uses are permitted within that classification. Sixth, parking requirements. Minimum spaces per dwelling unit or per square foot, often the most space-consuming requirement on the entire site. Height in particular is measured one way by zoning and another way by the IBC, and the difference matters. The IBC and the zoning code measure building height differently, and most architects discover the discrepancy only when their permit application gets rejected. The IBC measures from the lowest level of fire department vehicle access up to the floor surface of the highest occupied story. Mechanical penthouses generally do not count toward the top end. Sprinklers throughout the building unlock a 20-foot height bonus under Section 504.2. The zoning code, by contrast, measures from average grade, or sometimes from the center line of the adjacent street, up to the ridge of a sloped roof or the top of a parapet on a flat roof. Mechanical penthouses often count toward the top measurement. Some jurisdictions exempt them within a limited size. Sprinklers offer no zoning bonus. The same building therefore carries two different height numbers depending on which code you are reading, and both must satisfy their respective limits. A scheme that IBC limit easily can blow the zoning cap if the architect did not check zoning height separately at design start. The permit fails, the owner sues the firm for design negligence. FAR is the single most powerful zoning lever and the most commonly tested on the exam. 30,000 square feet. That is what an FAR of 3.0 yields on a 10,000 square foot lot. And the exam will hand you exactly that arithmetic to test whether you understand the relationship between FAR, lot size, and buildable area. FAR times lot area equals total floor area, period. What the FAR does not tell you is how to distribute that floor area vertically. 3 stories of 10,000 square feet each fits the FAR perfectly. So does 6 stories of 5,000 square feet each. So does a mixed tower scheme with a podium. The distribution is a separate problem, driven by the height limit, the setbacks that shape the footprint, and the lot coverage limit that caps the largest possible footprint. FAR controls density, not form. The trap is in the definition of what counts toward FAR. Some jurisdictions exclude basements, mechanical space, and parking. Others include them. Spec a scheme assuming basement parking does not count, only to find the local code includes it and the project is over the cap by 15,000 square feet. The owner sues and the firm absorbs the redesign. Walk away with 5 anchors that keep zoning and building code constraints aligned from kickoff. 5 takeaways from zoning impact on building design. First, 6 zoning parameters: setbacks, height limit, FAR, lot coverage, use classification, and parking requirements must all be verified at the project kickoff before any schematic line is drawn. Second, the IBC measures building height from the lowest level of fire department vehicle access up to the highest occupied story, while the zoning code measures from average grade up to the ridge or parapet. Same building, 2 different numbers, and both must be satisfied. Third, zoning and the IBC operate on parallel tracks. Neither overrides the other, and the more restrictive limit always wins on the permit set. Fourth, FAR multiplied by lot area gives total allowable floor area, and how that area distributes vertically is a separate problem governed by height, setbacks, and lot coverage. And fifth, before assuming any scheme fits the FAR, confirm what the local code counts toward FAR. Basement, mechanical, and parking inclusion rules vary by jurisdiction, and the wrong assumption blows the cap. Most architects assume base zoning is the end of the regulatory conversation, and you can lose months on a project before discovering otherwise. Overlay districts sit on top of base zoning, adding extra constraints, and occasionally adding flexibility, depending on the overlay type. Historic preservation overlays restrict materials and require design review. Floodplain overlays mandate elevated construction and ban habitable space below the base flood elevation. Transit-oriented development overlays trade reduced parking for increased density. Special design districts enforce material palettes and signage standards. Skip the overlay check at kickoff, and you discover the constraint at submittal, costing the project weeks or months on the schedule. Worse, you discover it after construction starts, and the Historic Preservation Commission orders the cladding torn off because the material was not in the approved palette, and the contractor sues for the rework cost while the owner sues the firm. 5 common overlay types cover most of the overlay landscape an architect will encounter. 5 overlay types cover most of the regulatory landscape architects encounter. First, historic preservation overlays. Design review with the local historic commission. Restricted material palettes. Height controls that often run below the base zone limit. And signage rules that protect the streetscape character. Second, floodplain overlays. Elevated construction with the lowest occupied floor above the base flood elevation. Flood-resistant materials below that elevation, and prohibition of habitable space below it. Third, transit-oriented development overlays. The rare overlay that loosens base zoning rather than tightening it, reducing parking requirements in exchange for increased height and mixed-use incentives near transit stations. Fourth, environmental and coastal overlays. Setbacks from waterways, habitat preservation, stormwater management mandates beyond the base code. Fifth, special design districts. Neighborhood-level aesthetic controls on materials, signage, lighting, and massing, often enforced through design review. Each overlay carries a separate ordinance, a separate review process, and a separate timeline. Design review itself is a sequence, and the sequence is what eats the schedule. 6 steps move a project through design review, and each step has its own clock. First, preliminary concept review. A concept presentation to the design board or historic commission before any detailed design work, so the board's reactions inform the rest of the schematic phase. Second, materials and finishes approval. Often restricted to a defined palette in historic and special design overlays, and proposed materials must be documented with samples. Third, massing and scale review. The board evaluates the building's volume against surrounding context, often requiring step-backs or facade articulation. Fourth, signage review. Size, type, and illumination of every proposed sign, including tenant signs that will be added after occupancy. Fifth, public hearing. Notice to adjacent property owners, opportunity for public comment, and a vote by the board. Sixth, conditions of approval. The board's vote often comes with required modifications that must be incorporated before the permit will be issued. Each step can add weeks or months to the schedule. Underestimate the timeline at fee proposal stage, and the firm absorbs the extra meetings. The defining behavior of overlay districts is additive, except in one notable case. The general rule is that overlay districts add requirements on top of base zoning. Historic preservation, floodplain, environmental, and special design districts all stack additional restrictions, and a project in any of those overlays must comply with both the base zone limits and the overlay rules. Neither relaxes the other. The architect's job in those cases is to identify the most restrictive layer for each parameter and design to that controlling limit. Transit-oriented development overlays are the exception that proves the rule. TOD overlays exist to encourage density and mixed-use development near transit stations, so they explicitly reduce parking requirements, often raise height or FAR caps, and sometimes grant mixed-use entitlements without separate approvals. The trade is that the project must demonstrate genuine transit proximity and meet TOD design standards, typically active ground floor frontages and pedestrian-oriented site design. The architect's job in a TOD overlay is to verify which incentives the parcel qualifies for and to design the scheme around the loosened constraints rather than the base zone ones. Missing the TOD incentives leaves entitlement value on the table that the developer expected to capture. Walk away with the 5 anchors that keep overlay risk visible from project kickoff. 5 anchors from overlay districts and design review. First, 5 overlay types cover most architectural practice: historic preservation, floodplain, transit-oriented development, environmental and coastal, and special design districts. And each one carries its own ordinance and review process. Second, the general rule is that overlays add requirements on top of base zoning, with the notable exception of TOD overlays, which loosen parking requirements and often raise height or FAR caps in exchange for transit station proximity. Third, design review is a 6-step sequence: concept presentation, materials approval, massing and scale review, signage review, public hearing, and conditions of approval, with each step having its own clock and its own potential for delay. Fourth, public hearings within the design review process require notice to adjacent property owners, and the notice period alone can add weeks to the schedule. And fifth, the architect's job, when overlays apply, is to identify the most restrictive layer for each design parameter and design directly to that controlling limit, rather than discovering the constraint at submittal. Most architects build entire careers within the prescriptive IBC, every detail traceable to a specific table, every assembly traceable to a specific section. You will eventually run into a project where the prescriptive code does not fit, and the question is whether you know what to do next. Prescriptive codes specify the means: a 2-hour rated wall, an 80-foot travel distance, a 1-hour fire barrier between this occupancy and that one. Performance-based codes specify the outcome. The wall must maintain structural integrity for 2 hours under standard fire conditions. Occupants must reach safety within a defensible evacuation window. Both approaches achieve code compliance. The performance approach is unlocked through Section 104.11 of the IBC and through the ICC Performance Code. But the burden of proof shifts onto the architect, and if the engineering analysis is sloppy, the building official rejects the alternative and the project loses fee, schedule, and credibility. Get the analysis wrong on an exam question and you fail the item. Get it wrong on a real project and the firm gets sued for malpractice. Side by side, the two approaches solve the same problem in opposite directions. Prescriptive compliance is the default and the easy path. You follow the IBC's specific rules exactly. Every dimension, every rating, every threshold lifted directly from the tables. Plan review is checklist driven, and the inspector marks each requirement off as your drawings show it. Standard buildings and routine designs sail through. The cost is inflexibility. A prescriptive code cannot accommodate an innovative atrium geometry, a unique structural system, or a hybrid occupancy that does not fit cleanly into the IBC's classifications. Performance-based compliance is the alternative path. The architect demonstrates through engineering analysis that the design achieves the same safety objectives as the prescriptive code, even though the means differ. The freedom is real, especially on complex or innovative projects. The cost is process. Plan review becomes slow because the authority having jurisdiction must approve the engineering methodology before the building can be permitted. The burden of proof rests squarely on the architect and the consulting engineer, and sloppy analysis is rejected outright. The owner sues if the project blows its schedule, waiting on approval that should have come faster. 5 scenarios make performance-based design the right call. 5 scenarios make performance-based design the right call, rather than the prescriptive path. First, large atrium designs where the volume exceeds the prescriptive smoke control parameters in Section 909, and an engineered smoke management analysis is the only way to demonstrate tenable evacuation conditions. Second, innovative structural systems, long-span trusses, complex seismic geometries, hybrid timber-steel assemblies that do not match anything in the prescriptive seismic tables. Performance-based seismic analysis demonstrates equivalent resistance. Third, fire engineering analysis for unique or hybrid occupancies that do not classify cleanly under Section 302. Large mixed-use complexes, research facilities with combinations of laboratory and assembly uses, transit hubs. Fourth, historic building renovations where strict prescriptive compliance would destroy the structure's historic character and is genuinely impractical, even with the Section 3412 historic provisions. Fifth, extremely large or complex buildings, stadiums, exposition halls, mega towers, where the prescriptive limits in the IBC are too conservative and the performance analysis demonstrates the building actually beats those limits on the metrics that matter. All of those scenarios run through one section of the IBC, and it is worth defining clearly. Section 104.11 of the IBC is the gateway to every performance-based design and every alternative materials approval. The text reads that the building official is authorized to approve alternative materials, methods, or designs not specifically prescribed by the code, provided the alternative is at least equivalent to the prescriptive requirement in quality, strength, effectiveness, durability, fire resistance, and safety. The 5 equivalency test is the operating language: quality, strength, effectiveness, durability, and fire resistance, plus the catch-all safety equivalence. The burden of proof rests entirely on the proposer, meaning the architect and the consulting engineer must demonstrate equivalency through laboratory testing, peer-reviewed engineering analysis, or third-party certification from a recognized listing agency. The building official has full discretion to accept or reject the demonstration, and rejection is final unless overturned through the formal appeal process. Get the demonstration right, and the alternative is approved. Get it wrong, and the project goes back to prescriptive compliance, with a schedule loss the firm absorbs. The architects who succeed under Section 104.11 build the case meticulously and submit it early. The architects who improvise lose. Walk away with 5 anchors that keep the performance path defensible. 5 takeaways from performance-based code alternatives. First, prescriptive codes specify the means, every dimension, every rating, every threshold, while performance-based codes specify the outcome and let the architect choose the means by demonstrating equivalent safety. Second, Section 104.11 of the IBC is the gateway through which every alternative material, method, or design must pass, with approval by the building official as the operating mechanism. Third, the burden of proof rests on the architect and the consulting engineer, and equivalency must be demonstrated through laboratory testing, peer-reviewed engineering analysis, or third-party certification from a recognized listing agency. Fourth, the 5 equivalency test in Section 104.11 requires the alternative to be at least equal in quality, strength, effectiveness, durability, and fire resistance compared to the prescriptive requirement, plus a general safety equivalence. And fifth, performance-based design is the right call on 5 typical scenarios: lodge atria, innovative structural systems, unique or hybrid occupancies, historic renovations, and extremely large or complex buildings, where the prescriptive code does not fit the geometry. Most architects walk into their first plan review disagreement believing the building official's interpretation is final, and you have probably accepted a red line you did not agree with rather than fight it. That instinct is wrong. The IBC gives the architect 4 formal paths to contest an interpretation or seek relief from a prescriptive requirement: alternative materials and methods under Section 104.11, modification under Section 104.10, appeal to the Board of Appeals under Section 113, and zoning variance through the planning authority. Each path has a specific purpose, a specific success threshold, and a specific failure mode. Pick the wrong path and you waste fee and damage the relationship with the official. Pick the right path and the project moves forward without sacrificing design intent. lose the appeal entirely, and the firm absorbs the redesign cost. Or worse, the owner sues the firm for the schedule slip. 4 options cover the contested decision landscape, and the right pick depends on the issue. 4 options, 4 distinct purposes. First, alternative materials and methods under Section 104.11, used when a different approach achieves equivalent safety to the prescriptive requirement. The architect proposes the alternative, demonstrates equivalency through testing or engineering analysis, and the building official decides. Second, modification under Section 104.10, used when literal compliance with a specific prescriptive requirement is impractical due to site constraints, structural limitations, or existing building conditions. The architect requests a modification of the specific requirement, and the building official may grant it. Third, the Board of Appeals under Section 113, used when the building official has denied an alternative or a modification request. The board reviews the official's interpretation and decision, with the architect making the case on the record. Fourth, zoning variance, separate from the IBC process entirely, used when the zoning code itself imposes a constraint that cannot be met due to a unique property hardship not caused by the owner. Picking the wrong path is one of the most common professional missteps. Alternative materials is not the right tool for a zoning setback dispute, and a Board of Appeals cannot grant a zoning variance. Variances are the most misunderstood path, and the requirements are strict. 5 tests must be met for a zoning variance to be granted, and most variance applications fail because they miss at least one. First, the property must carry a unique hardship, unusual topography, an irregular lot shape, an undersized parcel, or an unusual location that makes prescriptive compliance impossible. The hardship must be a property condition, not an owner preference. Second, the hardship cannot be self-created by the owner. Buying a constrained lot knowing the constraints does not create a defensible hardship case. Third, the proposed variance must not be detrimental to public welfare or to neighboring properties. The variance cannot reduce parking below what neighbors need or increase shadow impacts on adjacent lots beyond reasonable. Fourth, the variance must be the minimum necessary to afford relief. Applications requesting more than the property needs are routinely rejected. Fifth, a public hearing is required with formal notice to every adjacent property owner, and the hearing must be held before the variance is granted. Skip any one of these tests, and the variance is rejected. The project loses months, and the owner often sues the firm for relying on a non-defensible application strategy. The Board of Appeals and a zoning variance look similar from outside, but serve entirely different functions. Both the Board of Appeals and the zoning variance process involve formal bodies reviewing project-specific requests, and architects routinely confuse the two. The Board of Appeals, under Section 113 of the IBC, exists to review the building official's interpretation and application of the building code. The board determines whether the official applied the code correctly, and the board's decision either upholds or overrules the official's reading. Critically, the Board of Appeals cannot waive code requirements or grant exceptions. It can only determine whether the official was right or wrong on the specific reading. The board is the right path when an alternative materials request under Section 104.11 or a modification request under Section 104.10 has been denied, and the architect believes the denial was incorrect. The zoning variance process, by contrast, lives entirely outside the building code and inside the zoning authority. The zoning board or planning commission grants variances when the 5-part test is met, and the variance actually carves out an exception to a specific zoning requirement for the particular property. Public hearings with formal notice are required. Confuse the two on an exam question and you lose the point. Confuse them in practice and the firm files the wrong application, wastes months, and pays for the redo. Walk away with the 5 anchors that keep these paths straight on any contested decision situation. 5 takeaways from code modifications and appeals. First, 4 formal paths exist when an architect disagrees with the building official. Alternative materials and methods under Section 104.11, modification of a specific requirement under Section 104.10, appeal to the Board of Appeals under Section 113, and a zoning variance through the Planning Authority. Each path serves a specific kind of disagreement. Second, a zoning variance requires a unique property hardship, irregular topography, lot shape, size, or location, and the hardship cannot be self-created by the owner. Third, the variance granted must be the minimum necessary to afford relief, and a public hearing with formal notice to adjacent property owners is required before the variance is granted. Fourth, the Board of Appeals reviews the building official's interpretation of the IBC and decides whether that interpretation was applied correctly. The board cannot waive code requirements or grant exceptions. And fifth, picking the right path for the contested issue is half the battle. Alternative materials is not the right tool for a zoning setback dispute, and a Board of Appeals cannot grant a zoning variance. Most candidates read code as a list of rules to obey. The advanced level asks a different question. Where does the code leave room for judgment, and how do you walk that opening on the record? The IBC has seams. Mixed occupancy is a seam. Separated and non-separated are both legal, and the architect picks. Sprinkler standards are a seam. NFPA 13, 13R, and 13D are all correct for some building and wrong for the others. Areas of refuge are a seam that opens when sprinklers close. Zoning sits as an outside seam that constrains the IBC envelope, and Section 104.11 is the seam that becomes a tool when the prescriptive code refuses to fit. Naming the seam, picking the path, documenting the choice, that is the advanced exam, and it is also the work. The first seam, and the one with the largest cost consequences, is the mixed occupancy decision: separated, non-separated, or with incidental uses pulled out. 3 openings live above the basic occupancy stack. Separated versus non-separated is the largest one. It is a real strategic choice, not a determination the code dictates. Separated lets each occupancy keep its own limits, but extracts the cost of rated walls and floors between them. Non-separated drops the separations, but lets the most restrictive occupancy in the building set the limits for everything. Run both numbers and recommend the one that protects the program. Incidental uses are the trap people miss because the rules sit in their own table. IBC Table 509 calls out specific spaces, including boiler rooms above a certain BTU input and certain storage areas that require fire-rated separation even when the broader building is non-separated. And the special occupancies in IBC Chapter 4, high-rise above 75 feet, atriums, underground spaces, stack their own requirements on top of whichever mixed-use strategy was chosen. Forget the layered specials, and the envelope you size is the wrong envelope. Sprinkler standards open the second cluster of seams, particularly when the building is partially or entirely non-sprinklered. Pick the wrong sprinkler standard, and the rest of the egress logic unravels. The NFPA 13 family branches by building type. 13 is the full commercial standard with the deepest area and height bonuses. 13R is the residential standard for buildings up to 4 stories with narrower scope. And 13D is the 1 and 2 family standard with the lightest design. Areas of refuge are the rule that appears when sprinklers disappear. In any building with accessible egress, but without full sprinkler protection, each floor needs a protected place where someone using a wheelchair can wait for assistance. Add the sprinklers, and the requirement falls away. High-rise above 75 feet compounds everything. Fire service access elevators, additional stairs, smoke-proof enclosures, and the exam writes around the layering rather than the individual rule. Read the protection scheme first, then read the building. Reverse the order, and you protect against the wrong scenario. Two seams sit outside the IBC itself, the zoning code that constrains the building before code review even starts, and the documented paths when the prescriptive envelope refuses to fit. Three pressure valves live outside the prescriptive envelope. Zoning is the parallel system that constrains the building before code review even begins. Setback distances, height limits, floor area ratio, and use restrictions all run alongside the IBC, and zoning is often the stricter of the two. The architect honors both systems simultaneously, and on dense urban sites, zoning usually drives the envelope more than the building code does. The performance-based alternative under IBC Section 104.11 is the documented escape valve when the prescriptive path will not fit. The architect demonstrates equivalency to the building official by showing that the alternative meets the intent of the code, and the demonstration becomes part of the project record. And the Section 113 Board of Appeals is the formal dispute mechanism when the official and the architect disagree on interpretation. But it is a last resort, not an opening move, because every appeal slows the project and signals an adversarial posture. Reach for it sparingly. Reach for it deliberately. 4 takeaways close the gray zone discipline into the posture you carry into any code question that hides a seam inside the prompt. Walk away with the gray zone discipline rather than a list of facts. Mixed use is a strategy choice the architect runs deliberately. Separated and non-separated are both legal. The calculations get done both ways, and the recommendation lands on the path that protects the program rather than the path that is easier to draw. The sprinkler standard match is what makes the egress arithmetic work. NFPA 13, 13R, and 13D belong to different buildings, and the wrong standard either overprotects at unnecessary cost or underprotects and fails plan review. The layered specials are the rules that sit on top of the basic envelope and have to be inventoried up front. Areas of refuge in non-sprinklered buildings, high-rise additions above 75 feet, incidental uses requiring separation regardless of size, because finding them in design development means redrawing what should have been settled. And the documented escape valves close the picture. Zoning sits as the outside constraint. The performance-based alternative under Section 104.11 is the in-code path when the prescriptive envelope refuses to fit. And the Section 113 appeals process is the formal last resort that the architect uses sparingly. Read every code prompt for the seam inside it. Walk the seam on the record.